Let's understand how to design stateful services in Kubernetes in depth. The stateful design pattern is critical for applications that need to retain some form of state across multiple requests or sessions. This pattern is often necessary for databases, distributed systems, and applications require data persistence, session management, or transactional consistency. Let's explore the stateful design pattern in Kubernetes in detail, focusing on its components, configurations, and best practices. Overview: in a stateful application, each instance or pod in Kubernetes maintains some form of state information that influences its behavior and processing of future requests. This state can be session data, user-specific information, transactions, or any data that needs to persist and be consistent across interactions. Purpose: the primary purpose of a stateful design pattern is to ensure that applications require persistent state can operate reliably and consistently. Unlike stateless applications, stateful application needs to manage data continuity, often necessitating specialized storage solutions and configurations. Let's understand few key components. Stateful sets. Kubernetes object designed to manage stateful application. Stateful sets ensure that each pod has unique and stable identity, ordering, and persistent storage. Persistent volume (PV). A piece of storage in a cluster provisioned by administrator or dynamically provisioned using storage class. Persistent volume claim (PVC). A request for storage by a user. Pods uses PVCs to request PVs, which means that if pod needs some data, they will use PVCs to get data from PVs. Headless service that do not provide load balancing or single IP address. They enable network identity for stateful set. Now let's understand steps. First, design your application. Ensure that your application can manage state and recover from failure. Design it to work with persistent storage solutions. Then create Docker image. Package your stateful application in a Docker image. Ensure it is optimized for reliability and data consistency. Then third is define persistent storage. Create a persistent volume. As in a sample YML file, you can see that capacity of this persistent volume is 10 GB. Resource access is read write once, and its path is given where this data is available. Then comes that allocated storage with persistent volume claims. In this YML file, you can see that it is persistent volume claim. It says access mode, and then it accesses the metadata which you have defined earlier. Fourth is define a stateful sets. Create a stateful YML to manage deployment and scaling of stateful pods. Here first you can see its name is stateful service, and then its kind is stateful set, which is provided by Kubernetes, and then rest of the things, volume, claim templates, and its access and its storage and everything. Then you apply the stateful sets. Then sixth is that you create a headless service. Define a headless service to provide network identity for a stateful set. It's a basic service which access the stateful service which you have created just above. Then comes the key parameters. Stateful set configurations, replicas as basic thing. Then service name is stateful service. Then volume claim templates. In this one, you have defined metadata for access mode, how much storage you want, and all these details. Then if you have to configure capacity, access mode provides you how you want to read and write to the storage. Then let's understand pros and cons. Data persistence ensures that data is retained and consistent across restart and failures. Stable network identity. Each pod has a stable network identity facilitating state management. Ordered management, deployment and scaling. Pods are created, deleted and scaled in a predictable order. Volume management. Each pod can have its own persistent storage managed through persistent volume. Cons, it's very complex. Scaling is very complex. You cannot horizontally scale. And then it's very resource intensive as you have to manage a lot of resources, which becomes a bit tricky, and compared to stateless applications, it becomes very challenging. Then these are the few best practices. Design it for resilience, use storage which is provided to you, implement robust health check, configuration management, and then backups and CI/CD. Let's understand use cases. Main use cases are databases. Stateful sets are ideal for deploying databases cluster. Example, MySQL, Postgres, Cassandra that require data persistence and consistency. Distributed system applications like Kafka, Zookeeper that require stable network identities and persistent storage. Session management application that need to manage user sessions and state information. Transactional application system that handle transactions require transaction persistent and consistency. Persistent caching systems like Redis with persistent. If you want to set up those, then stateful will be very helpful in those cases.